Have you ever stopped to think about how a programming language, the one named after that British comedy troupe Monty Python, how did it go from this like quirky beginning to being this absolute giant in tech, everywhere you look almost? If you're interested in what makes digital stuff tick, well, you're definitely in the right place. Welcome to the deep dive. Today we are really getting into Python. Now, yeah, you probably know it's super popular. That's kind of common knowledge now. But this deep dive, it isn't just about what Python is. Our mission really is to unpack why. Why is it still growing like crazy? And how advanced, how essential has it actually become? We're digging into this fantastic research paper called Python, the most advanced programming language for computer science applications. It's by Dhruv, Patel, and Doshi. It's just packed with stats, great examples, the core stuff we really want to get at. We want to help you understand not just the features, but the huge impact it's having everywhere. So what's on the agenda today? Well, we'll kick off with the origin story, which is pretty fun. Then we'll explore its main characteristics, its data structures. From there, we'll really dive into the libraries. That ecosystem is just, wow, so many applications. We'll also try to demystify how it handles memory, which is kind of unique. Look at the stats showing its rise. And finally, touch on frameworks for web development.
Okay. Hey.
Let's get into it. Let's start right at the beginning. 1991. Guido van Rossum creates Python. But the name story is the best part, I think. He needed something short, unique. Apparently, he was reading scripts from Monty Python's Flying Circus. And boom, Python. Kind of a playful start for something so, well, powerful now.
It really is. It's funny how that lighthearted name sits on top of such a solid design. Fundamentally, Python is object-oriented. It's interpreted. And it's really interactive. And these aren't just buzzwords, right? They're key to why it's relatively easy to learn, but still incredibly capable. If you look under the hood, you get these high-level data structures built right in. Things like lists, tuples, sets, and dictionaries, which are basically powerful associative arrays. Plus, it uses dynamic typing and binding. It supports modules, classes, exceptions, and maybe most importantly for developers, automatic memory management. All this stuff simplifies things a lot. Lets programmers focus on the actual problem, not the fiddly low-level details.
Yeah, the paper really stresses that. It says, and I'm quoting here, a comparatively simple and easy syntax for coding, even though it's a powerful programming language. What's that? It feels almost deceptively simple when you start out, right? That low barrier to entry seems like a massive advantage.
Oh, absolutely. A huge draw. And that simplicity, combined with this enormous library ecosystem, that's what shot Python to the highest peak in terms of machine learning, as the paper puts it. They point out its varieties of library, reduces the code to 1/3 for programmer. I mean, think about that.
1/3.
Yeah. Way less code means faster development, fewer bugs, and just a much quicker path from an idea to something real, especially in complex fields like AI.
Right. And speaking of making code work well, let's talk data structures. We know generally they're about organizing data efficiently. But what's special about Python's approach? And what about those specialized tools mentioned?
Well, the basic ones Python gives you are super intuitive. You've got lists. They're mutable, ordered. You define them with square brackets, like list 1, 2, 3. Simple. Then dictionaries, sometimes called hash maps. They pair elements with definitions, like dict1.a2.b. Really flexible. And sets. These are unordered collections of unique items, immutable items, actually, defined with curly brackets, too, like set 1, 2, 3. These built-ins just handle a lot of common tasks very cleanly. But yeah, beyond those basics, there are specialized tools for when you need more performance or specific data handling, like Cython. Its whole job is to significantly improve the speed of the implementation of the code. So for bottlenecks.
Ah, okay. Speeding things up.
Exactly. Then you have PY tables. That's built for maintaining hierarchical data sets, and it can handle extremely large amounts of data. Think massive scientific data sets. And TreeDict. The paper describes it as a container that simplifies keeping track of parameters, variables, data. It says it's very stable and fast at work. So these tools really show how Python builds on its core, which leads us to the libraries.
Okay, yeah. This is where, for me, it gets really exciting. I think this is a huge part of why Python is just everywhere. It's the sheer number and quality of these built-in libraries. This ecosystem just unlocks Python for, well, almost any computer science field you can think of.
You've hit the nail on the head. It's not just a bunch of tools. It's this powerful, network effect. Developers come to Python because the tool they need probably already exists, which brings more developers, which leads to more tools. It's this cycle that's really hard for other languages to match. Let's maybe walk through some key areas.
Yeah, let's do it. Where do we start? Data science seems huge.
Definitely. So in data science, you've got cornerstones like Matplotlib. It's not just for 2D plot graphs, it's fundamental for visualizing data, understanding it. Pandas provides those essential data structures and tools for analysis. Think finance, stats, social science.
Right. Pandas is everywhere in data analysis.
It really is. And NumPy, often called the